whenever we take for the observation, okay, what is mean by the observation means how the how data is represented we are observing. Okay, how the data is represented we are observing. Let us take an a two particular in whenever we go with an observation in generally we take an a two particular variables. Okay, whenever we call a variables also called as an a calls. Okay, columns. Okay, columns, variables or columns. In generally what we are going to do here means observe. Here also we have few things we need to consider when we are considering two particular variables we call bivariant. Okay, univariant means single variable consideration or single variable observation. Here whenever we take an two particular variables, one is the x variable we are going to be considered. Okay, now the x variable is an independent variable. Okay, and we call it as an input data also. Input data. Okay, next y variable which is an dependent on x variable where we consider this particular thing, where we are going to be considered this particular thing output also. Okay, output also x and y variable, two observations we are considering here. Okay, now whenever we come to here, okay, now these two particular relational variables, that is one more thing we need to consider. What we need to consider for the observation of the linear regression, the variable should be in a relation. Okay, relation variables. What is mean by an a relational variables? Observe careful. Based on the x data, based on the based on x data, y should vary. Y should vary. Okay, now whenever we call the variation, okay, it may be there will be an increment or decrement. We can't say that. See, whenever the temperature is increasing, whenever the temperature is increasing, the sales of ice cream and the cool drinks also increasing. Temperature increasing, sales of ice cream and cool drinks are increasing. But if you observe the same time, whenever the temperature is increasing, whenever the temperature is increasing, the sales of an sweaters and something is getting an decreasing. Means there is an a relation, there is an a particular relation between a temperature, ice creams of cool drinks and sweaters and some related stuff to temperature. This may be the positive relation, this may be the negative relation, but there is a relation. Okay, and there is a relation. Now here the same concept we are going to be considered in the regression, x variant and y variant. Okay, x variable, y variable. Wherever the x data is getting increased, wherever the x data is getting increased, okay, the y variant also getting increased because the y variable is a depend on the x variable. Y variable is a depend on the x variable. Y variable depend on the x variable. Now what is the thing we need to see here means observe careful. Observe careful. This is any sometimes there will be any increment in this particular pattern where x is increasing, y is getting increased. And sometimes we are going to see in this particular aspect, okay, in this particular aspect, okay, and other thing we are going to see, okay, or else slight change. Okay. Now, by this particular represent the observations, whenever we are giving an observations between, we are observing the relation between two particular variables, where x variable, y variable. Consider this is an x variable, this is an y variable. Okay, just to take into the consideration, simple consideration. Now, why it? Let us discuss about an first line of an this particular light blue color, where the line is starting from the zero. Okay, x value is 0, y value is 0. X value is something, y value is something. That's why the linear line is an straightly it is increased in this particular pattern where it is starting from the 0. Okay, okay. When this concept we are going to utilize, we will see examples. Now the next thing, the x value and y point, x point, y point, it is starting, x point is starting from here somewhere. We can consider it is coming from the negativity. Number two, if we start discussing in this particular pattern, number two, and it is getting slightly the increment it is taking into picture, slight increment here it is taking. Okay, where it is starting from negativity. Okay, now the third line, black line, this is, let us consider, observe, this is called, these points are called, wherever the points it is starting from, these points are called intercept points. What is these particular points are called? Intercept point. What is that particular intercept point? It is a very important point. Very important intercept point is a very important point. Observe these particular intercept point, how we can justify these particular intercept appointments. Let us consider one of the ex person, he got a job in MLC, one of the multinational company. Okay, he has a 0 years experience and he is getting a salary, average salary of an 3.5 lakh per annum, 3.5 lakh per annum. Now with the 0 years of experience, he is getting something. Zero of zero not. Here, if we consider this is an experience and this is an a salary, y-axis and a salary. Now, with an a 0 years of experience, x value, what is the x value? 0 years. What is the y value? It is starting from here. Did you get it? The point. It is starting from 3.5 years. This is an intercept point where we are going to be as the years of experience is increasing, the salary also getting an increased. Okay, now this is also same thing, we can consider the fourth line where at the 0 years of experience is getting paid. The person, we will see IIT somewhere, what's their salary? It's a huge with a 0 years of experience. Maybe we are considering from here. Then observe careful one more thing, the sliding of this particular line of number 3. If you observe the sliding of the performance of the number 4, it is an straight in the bit increment state, but it is the increment growth is an very low. Increment growth is very low. Depends upon your observations, the data is going to be incremented in this particular. He has a huge increment, he has getting not an increment. Okay, now this kind of an observation, observation is a simple observation. Okay, now here we are going to be considered the particular formula for the linear regression, where this particular formula is a slope formula of a physics. What is the slope formula? Y equal to, we are going to take y equal to mx plus c. Okay, this is a particular formula we are going to consider to work with the linear regression. What could be the formula for the linear regression? Y equal to b naught plus, observe, it looks like y equal to b naught plus b1 x1, b1 x1. Okay, we elaborate this particular formula. What are the objects inside this particular formula? Okay, this is a basic formula of a linear regression. If you go for the multilinear regression, how many variables you have, that many x points you're going to get. It means something I have a particularly four variables. Okay, in this particular four variables, input data, how many? Three variables considered as an input data, and one variable is considered as an output data. Means three variables are going to be look like this: x1 of x2 of and x3. Okay, and one output, no, y1 directly. Okay, y variable or y1. Okay, it is going to look like this. Okay. Now let us start a consideration where we are going to be utilize this particular uh, formula, linear regression. Okay, where we are going to utilize this particular thing. Let us take into the consideration about an salaries, employee salaries or something. I am taking into the consideration x variable and y variable. Based on the x variable and y variable of an two different objects, I am taking an observation. Okay, observation. Now observe here, first point, let me consider this is my first point, second point, third point, fourth point, sixth point, like this, seventh, 8, 9, 10, 11, 12, like these observations I have. Okay, now try to understand these observations. Try to understand. This is an x-axis, this is an y-axis. Okay, this is an x-axis, this is an y-axis. This type of plotting, we know that scatter plot. Okay, scatter plot. We have taken the observations. We are observing these particular observations in the graphical representation of what is the relation of an data. I don't know, someone is joining and quitting, or what's the issue? Trying to join, or that's okay, that's fine. Now let us take into the consideration observations where what I'm going to take here is the same as an experience. Observe careful, experience, okay, and a salary. Now I am not taking the independent person growth. Previously, what I have taken in previous graph, the X person observation from 12 years, from 0 to 12 years, I have observed the X person observing. So I got a linear line. I got a linear line. But here I have an employees, means almost, let us take an employees of employees. Different kinds of an employee salary in the organization I have taken into observation, where based on their experience, how much salary they are getting. Now, whenever I take an assumption line, assumption linear line, I'm getting like this. Assumption linear line, I'm getting like this. What is mean by this? How this assumption linear line I'm getting here? The first most important thing we need to discuss here is the intercept point. What is this intercept point? This particular intercept point is nothing but at an 0 years of experience, the y person, means at the y variable. What is the y variable? Salary. Hope everyone know these points, x comma y. Whenever we are taking graphical representation, x comma y, we are going to be taken here 0 years experience with a 3.5 lakhs or something salary. For every person who is joining with an 0 years of experience, or some people, they are, let us consider they are starting at an 2 years of experience, he's getting some salary. Okay, as per right now our discussion is with an 0 years of experience. This is the person name called A. Okay, let me change the color. This is the person name called A, B, C, and D, E. I'm taking 5 observations. Okay, F. Okay, 6 observation. Let me take 6 observation. I'm taking the 6 observations. How I got this mean line, I'm going to explain you. Okay, just wait it. This is an assumption linear line, assumption linear line. I want to justify this A, B, C, D, E, F employees. What is mean by an justification for the organization? Try to understand based on the A experience. I am discussing about the A person. Okay, I am discussing about an A person. Okay, A person based on his experience and his salary. I'm trying. Actually, he need to get the salary of whatever the line is the blue line, but he is getting a somewhat increment. Now let us take into an a C person based on his experience and he is getting an a some salary, but actually he need to get this gap of an a salary. He need to get this salary, but he is getting less amount of salary. Now if we go for the D, D is getting an a bit high salary compared to this one. How I know that this particular person need to get justified? How I got this particular linear line? This linear line will get from mean values. Okay, mean values of an x and y, mean values of a x and y. Whenever we take the consideration of the mean values of all the x and the mean values of all the y, we are going to get this particular linear line, where this particular linear line justify each and every employee whether he is getting any perfect. See, the simple thing as the where am I? Yeah. As the x-axis getting an increment, the y-axis need to take an increment value that is considered as a linear mean value. Okay, but this is my assumption line. Blue line is assumption line. In the real time observation, the red dots are we are getting. Now what is my thing? I need to eradicate. This is we considered as an error. Did you get it what I'm saying? Aishwarya, Ankit, Nikit, sorry, Nikit, Shilpi, Padma, Ram, Shiva, Triveni. This is called an error. This is called as an error. Let us take a, okay, don't get an confused. We call it as an a best fit line. This particular blue line we consider as an a best fit line. Let us go with an one best example where pre-written example. Give me a second. It makes us to understand perfectly. See here, let me take any. Okay, okay, here I'm taking only the single variable. Okay, single variable. The best fit line I am drawing here is a univariant. We can call it as a univariant here. Whenever I go with an univariant, the observations I given in this particular pattern. If we go consideration about a linear line, this is a linear line. How you got this particular linear line? Let us take into a small discussion. Okay, a plant manager want to know when employees arrive at work. Okay, shift starts at 8:30 a.m. She takes 5 random cards and plot the minutes of arrival on a card. Okay, they have taken a particularly 5 random observation. Whenever we take a random observation, these are the names A, B, C, D, E are the names, and the minutes after 8. A is coming at 37 minutes. What is an exact time? 8:30 a.m. Okay, 37, 25, 27, 36, 35. These are the points has been A point is an 36. Did you get it? X and Y. Observe the X and Y here. Okay, this is a time card X and these are the minutes. A is at this point, B at this point, C like this. Okay. How? What is the mean value? Here we can consider the mean value they have given, but blindly we can't go in that particular pattern. We need to take any mean. How we need to take an mean? Sum of objects, sum of observations by number of observations. You will get an mean formula. Mean formula. You're getting an 30. Okay, you're getting an 30. Now what we are doing here, observe here, what is mean? Y equal to mean, best fit line here. Okay, now this particular best fit line, what we are doing here, sum of mean square error. Oh, this is an error we need to identify. What is the error here? Plus 7 minutes minus 5 minutes. This, did you get it? 37 minutes. He's coming at 37. He's getting at 25 minutes, 23 minutes or something, whatever he is getting at 27 minutes, 25 minutes, 25 minutes, and 6 minutes of delay. Okay, like this, we need to identify the error. Now, what is our thing here? This is a practical example. In this particular practical example, we need to intimate, okay, Shilpi, not really, you didn't get it, yeah? Just we go with an 2 to 3 examples, then we will consider here, okay? Okay, now, see here. This particular pattern, in this particular pattern, we are seeing this, these are things we are considering. In a practical point of view, we need to intimate the labor to arrive at any earliest time or nearby time. That is a practical thing. But whenever we come to here, we need to reduce the error. We need to reduce the error. How to reduce the error? We are doing we have a multiple scenarios how to reduce the error. In this particular pattern, square root, we are going to do it. Means first square mean error, identifying the square mean error. Means observe careful here. I got an error of something like a plus 7. No, root of plus 7, you will get an some value. Did you get it? Whenever root of a plus 7, you're getting an some value. I'm saying roughly, it is not an exact value. 2.67 or something. I'm saying that 2.67 means plus 7 value is an a more compared to 2.67. Still, I want to reduce the value, means what I need to do, 1 by root 7 equal to 0.67 something roughly. Means this is the least error value where I can decrease least error value. This is called the variance formula where we are utilizing here. Okay, means decreasing the error value in multiple points, means multiple aspects we have where we can work it out. Okay, slowly we are going to be work it out. Now let us take into the consideration of one more example, and before entering into an example, let us see one small thing about this particular formula. Observe here, y cap, y equal to b naught plus b1 x1, where this is a linear formula. Okay, where y is a dependent variable and x is an independent variable. Now, if you observe this particular formula, how it is going to, y is a dependent variable, x is an independent variable, b1 is an coefficient, okay, coefficient, and b naught is an considered as a constant and also variant. Where we are going to be constant means in some aspects, if you observe, where it went, what we call intercept point. Okay, intercept point. In this particular intercept point, if you observe very clear cutly, 3.5 lakh, 3.5 lakh, something if we observe with an 2 years of experience. Okay, 2 years of experience. This one is an x variable, this is an y variable. Okay, now 2 equal to 3.5 lakh plus B naught we need to identify of X1. What is an A? What is an X1? What is an X1? Okay. I have said that X1 as an a 3.5. No, sorry. Here, intercept point. Okay, intercept point equal to 3.5. Okay, okay, and where X equal to experience. Okay, experience how much I am taking here. Suppose let us consider I am taking an okay 2 years of experience. Okay, y equal to his base salary. Intercept a point here. I am taking an base salary. One second. We have a small confusion pattern. Okay, why to worry? Observe here what I am doing here. Salary B naught plus B1 into experience. Simple way. Here what I am doing here. This is an a 30K is an a 30K is an a intercept point where I am taking an a these particular point in this particular aspect, and this is called as an increment. Plus 1 year is getting an increment. Okay, and how many years of experience? 1 year of experience. We are here identifying the what we are identifying, the B1 we are identifying. What is his base salary? His base salary is an something 3.5. Okay, equal to 30K increment here, and B1 we need to identify into of 1 year of experience. Whenever we start working out this one, we are going to be elaborate. But this particular B naught, sometimes we need to identify the salary, sometimes we need to identify the intercept point, sometimes we need to identify the B1. This is totally depends upon, because X value always given. X value input data always it will be declared. Observe here. Sorry. See here, what is our particular formula? Y equal to mx plus c is a physics formula, where y equal to b naught plus b1 x1 we are taking here. How many variables you have? That many variables. Here directly we are considering y equal to an output data. Okay, and which is an dependent variable. Okay, and x is equal to an input data. Okay, and where we are taking into the consideration it is an independent variable. Now whenever we take into the consideration this one, b1 is what is a b1 we are considering here? Coefficient. This coefficient here, okay, this is a coefficient where we are saying this is the pattern. Okay, b1 as a coefficient. Okay, b naught we are considering it is an intercept point. Okay, intercept point. Now in this particular formula, we based on the requirement, sometimes we are going to be identify the coefficient based on the requirement. Sometimes we are going to be identify the salary, means output variable. Okay, and the next thing, if you observe, X we never identify, because based on the input data only we need to identify B1, Y or B naught. B1, Y or B naught. Based on the our requirement we need to consider. Now to work with this particular linear regression or all the regression models, we need a package which is called as a scikit-learn. Scikit-learn package. If we observe this particular scikit-learn package, it will hold all the related stuff to and machine learning and deep learning and NLP. What are the stuff it is going to be holded? Models, method names, packages, all the things are going to be holded in the scikit-learn. Now we need to import the scikit family to working environment like this. Import sklearn dot family import model now, or else you need to call in this particular pattern from sklearn dot linear underscore model import linear regression okay. In this particular aspect you need to call these all the stuff to our working environment. And let us take into one more small example between for the linear regression. Give me a second. See here, observe here. A manager want to find the relation between the number of hours that a plant is operational in a week and weekly production. Means how many hours the plant is operating and weekly production he want to identify. Now observe here. In this particular independent variable x is an hours we are considering of operations, and a dependent variable y is an production volume. X and Y clearly mentioned, and this manager develops the following table: 34 hours production 102, 35 hours 109, 39 hours, like this we are getting. Now plotting the points in this particular pattern. Okay, here try to understand here the graph. If I start to draw the graph, how we are going to get it here? From where it is starting, the base value 30 hours, okay, for 30 hours, but it is starting at least from that 34 hours X value. That's why the points are starting from here, okay. Now, if we consider the linear line from the 30 hours, how do you got this particular linear line? How did you got it? Means mean. When we are taking the mean value of these particular things, we are getting a particular linear line. Okay, now observe here. Here, this is a particular formula where we are going to utilize to work it out. Linear regression formula. Y equal to B naught plus B1 X1. Now observe here in depth of this particular formula of an a B1 coefficient. What is an a B1 coefficient? How it is going to be elaborated? This is an a particular thing, sigma of an x minus an x cap, y minus of y cap, sigma of x minus x cap whole square. What is an x cap you are calling here? X cap is nothing but an a mean value. Mean value. X cap is nothing but mean value. Now what you are doing here, first you are identifying an a B1. B1 34 minus, if you observe, each and every value is going to be calculated. 34 minus mean value and 102 minus mean value, each and every object, each and every observation calculated in this particular pattern. Now if you observe here, x minus x cap, y minus y cap, and x minus x cap into y minus y cap, and x minus x cap whole square, all has been substituted here. Once we substitute this particular thing, if we observe B1 equal to what we are getting, what is the value of an B1? You're getting a 4.5. Okay, once we calculate, and B naught equal to y cap minus B1 into x cap, 134. What is mean by 134 minus 4.5? Where did you get it? 134. 134 is an a y value. Did you get it here? Mean value here. Mean value this one, mean value this one. X cap, y cap value. Okay, we are taking this x cap, y cap value here. That's the thing we are observing here. Y cap minus B1 X cap, 134 minus 4.5 into 40 equal to minus 46 we are getting here. This particular thing we are substituting here, Y cap equal to minus 46 plus 4.5x. Okay. Now, if we here try to understand this particular scenario, based on the formula, if the manager want to produce 125 units per week, the plant should run for how many hours? 125 equal to, here we get an output. 125 equal to minus 46 plus 4.5x. Here 38 hours per week. If you run, you will get an 125 units per week. Okay, just we recap once again how this particular thing is going to be comes into the picture. Observe careful. What is our scenario here? A manager want to find the relation between the number of hours that a plant is operational in a week and a weekly production. Okay. And here the independent variable X has declared as a hours of operation, and the dependent variable is a production volume. Simple. Okay. Two variables for the observation. In this particular observation, randomly 5 observations they have considered. 1, 2, 3, 4, 5, 6. 6 observations they have considered. Okay. Now, in this particular observation, I sent to a graph. Okay. And always when you are working with a regression pattern, mandatorily you need to identify an X cap of a Y cap. This X cap and Y cap, it will make us a linear line. What is an X cap? How you identify X cap and Y cap? Sum of observations by number of observations. Okay, means here you need to add all the objects by 6. Now sum of all the observations by 6, then you will get the mean value. This is the particular mean value you're getting. Where the mean value we got it, this is the line, and this is the mean value. 40 and 134 are the mean value for this particular thing. Now observe careful, what is our particular linear formula? Y cap equal to y equal to b naught plus b1 x1. Okay, now here we are considering b1 as a particular formula. Okay, it is not written by me, some scientist. We are utilizing this particular formula. We are not creating or elaborating this particular formula. The formula already has been designed by some X person. That particular formula has been utilized constantly from particular years. We are utilizing that particular formula. Now, if we observe, there is an a B1 formula and a B0 formula. In this y equal to B0 plus B1 x1. Now we are saying that B1 is an a coefficient. Okay, it is also an a true, and B0 is an intercept point. This is also fine. Okay, and now if we observe, based on the scenario, B1 has a particular formula where we need to apply this particular formula. This is a very important thing we need to keep in your mind, because we don't, in your practical sections, we don't elaborate this particular formula manually. Directly, if we call the linear regression model, it will do the entire work and we will get a particular result. But the thing, manually for the interviews, we need to keep in our mind these particular formulas. Now, what is the B0 formula? Y cap minus B1 X cap. Okay, B1 formula. Now, first, let's elaborate these two particular formulas. What I am doing here, calculated. And what is the B1? This is a particular formula, 555 by 558 by 124, 4.5. And again, I am elaborating a B0. B0 also you need to elaborate. What is the B0? Y cap minus B1 X1. Once I elaborate that particular formula, I'm getting minus 46. Now y cap equal to minus 46 plus 4.5 of x. Now if you observe here, this is an a y cap mean value you have, and x input data we can consider here. Okay, x we have constant. Now what you are identifying here, what you are declaring here, you are declaring, you are identifying the based on the output. Try to understand, based on the output, okay, identifying the some input. This is an inverse pattern, inverse pattern. What you are declaring here, based on the output, you are identifying the input. That's it, no? Based on the formula, if the manager want to produce 125 units per week, 125 units per week, how many hours we need to work it out? 125 equal to minus 46 plus 4.5, x value 38 hours per week. 38 hours per week. Not only in this particular aspect, we can work it out in the multiple aspects. Now, if we go on multi-regression, multilinear regression here, what is mean by a multilinear regression? Observe careful, multiple variables we are utilizing multilinear regression. Okay, multilinear regression. Previously, what we have taken here, linear regression, multilinear regression, where output value, it will be only one. X values depends. X value may be for the observation x1, x2, x3, x4. How many observations you have, that many X values you need to consider. You need to consider here. Something the formula looks like this. How the formula looks like, y equal to b naught plus b1 x1 plus b2 x2 plus b3 x3, like this. Go on, you're going to get it in this particular pattern. Now let us take a simple example. Simple example. See, for example, a used car lot made to know what variant affected net profits. They could create a list of the predictors that might correlation with the profits. What is the things? Price, age, brand, color, style. Price we can consider as an Y variant, and age, color, brand, style we can consider as an X variance. Now price and age are making an a most affectable. If you observe, they could want to measure the correlation of each variable to net profit. However, some prediction might correlation between each other, means price age making as an a nice difference here in the multilinear regression, where age is changing, the price is changing. They are means if you observe who is the at the age of an at 25, some people they are ready to pay for the 4.5 lakh per the car. When the age is an at 30, maybe some people, some people they are ready to pay for 9 lakh per the vehicle or something like this, or something like age at 35, they want to pay at 10 7 lakh. Depends here totally. 40 years of age, maybe they are ready to pay 8 lakh, like this. Means instead of these particular three variables, these two particular variables playing an important role in identifying the correlation of the profits of used cars, net profits of any used cars or the things. Now, I hopefully know that you're getting a confusion in this particular stage one, but don't get into any confusion step. We go with an multiple examples on the linear regression. Okay, just we go with a simple example tomorrow, and we start working on this particular linear regression tomorrow. Okay, and please go with a particular formula. First thing, we need to go with a particular formula. If we go with a particular formula, it will be very good. Okay, y equal to b naught plus b1 x1. This is a simple formula, but internally if we go, b naught have an extension. Okay, b1 has an extension. Okay, these two These three particular formulas we need to take into the consideration to evaluate the things, to evaluate the linear regression. But if you observe, just the formula we need to know, but we don't utilize these type of formula in the real time. Okay, directly we call the model and we start utilizing the model. Okay, is everyone okay up to here? Is everyone okay? Yesterday I have shared few questions. Did you go with that particular questions? That's the particular questions or the simple questions from Python actually. And I'm expecting close today that particular questions. Okay, Nigit, start working on that one. Shiva, Padma, everyone I am expecting, please work. Okay, okay, that's good. I'm closing the section for today. We continue tomorrow.